3 hours. That's all it takes. 3 hours without power during a 105-degree heat wave, and the temperature inside a tiny house climbs 10 to 12 degrees. For a 70-year-old living alone, that's not an inconvenience, it's a safety issue. Every month, retirees watch videos about tiny houses, dreaming of no mortgage, no rent, no utility bills draining their Social Security. And yes, the math can work, but here's what almost nobody says. Most tiny houses today were designed for short-term lifestyle use, not for a 75-year-old whose balance has changed and who cannot afford the wrong housing decision. Today, we're going to look at 3 things most channels skip: how a tiny house behaves when systems fail, whether the design truly works for an aging body, and the one question you must answer before signing anything. Tesla has not released a production tiny house. This is a technical analysis based on engineering principles and known design philosophy. I'm not selling you anything. My job is to help you ask better questions before anyone gets your money.
When the system fails, does a tiny house give you time? Let me tell you about a scenario that is not hypothetical. It is 2 in the morning on a Tuesday in July. You're in Phoenix, Arizona. The overnight low is still 94 degrees. Your air conditioner trips the breaker, something that happens in older units under heavy load. You wake up disoriented. The room is already warm. You check the thermostat, 82 degrees and climbing. You have a decision to make. In a traditional 1,800-square-foot home, that situation is uncomfortable. The thermal mass of the structure, the walls, the concrete slab, the multiple rooms of air, absorbs heat slowly. You have time. Maybe 3 or 4 hours before the interior becomes genuinely dangerous. In a poorly designed tiny house, that window can shrink to under 90 minutes. Here's why. A standard tiny house contains between 3,000 and 5,000 cubic feet of interior air volume. A traditional home contains 4 to 5 times more. That difference isn't just about space, it is about buffer. The smaller the air volume, the faster the temperature swings when mechanical systems stop working. Most tiny houses on the market are built around what engineers call a comfort-first design. The HVAC system does all the work. When it is running, everything feels fine. But that design has one critical vulnerability. The moment the system goes down, the structure itself offers almost no protection. The walls are thin, the volume is small, the heat builds fast. Tiny houses don't fail because they're small. They fail because they were never designed for what happens when things go wrong. The alternative is a failure-tolerant design, where the building envelope itself acts as the first line of defense before the HVAC system ever turns on. Based on engineering simulations and structural material research, a properly built retirement-grade tiny house would need wall panels with a thermal resistance of at least R24 to R28. To give you context, standard wood-framed homes run R13 to R15. Nearly double the insulation isn't a luxury upgrade. It is the difference between having 6 hours to respond and having 90 minutes. But insulation alone is only half the answer. The other half is passive airflow, and this is where most tiny houses fail completely. A thermally safe tiny house needs 3 things working together: a ridge vent system that allows hot air to escape through the roof without any mechanical assistance, a floor plan that prioritizes the bedroom as the most thermally stable zone in the structure, and low-emissivity glazing on every window, the kind that cuts solar heat gain by 30 to 40% before it ever enters the building. Without all 3 of those elements, you do not have a safe structure. You have a sealed box with a good air conditioner. And when that air conditioner fails at 2 in the morning, the box does not forgive. The right question to ask any tiny house manufacturer is not how good is your cooling system. The right question is, if the cooling system fails completely for 6 hours, what does the interior temperature look like? Any manufacturer that cannot answer that question clearly does not understand who they are building for.
And here is something even more important. Temperature inside a small structure does not rise in a straight line. It accelerates. The first 30 minutes may feel manageable. The next 30 minutes feel uncomfortable. But once interior surfaces, walls, ceiling, cabinetry begin absorbing and re-radiating heat, the rise becomes exponential. What felt stable at 82 degrees can become 90 before you fully process what is happening. Engineers call this thermal lag and rebound. In larger homes, that rebound is slow because the mass of the structure absorbs and disperses energy gradually. In compact volumes, there is nowhere for that energy to go. The air heats, the surfaces heat, your body heats. Retirement housing is not tested on good days. It is tested on the worst night of the year, when you are tired, alone, and something mechanical stops working. If a tiny house cannot show you a heat curve for a 4 to 6 hour failure window, then it has not been engineered for retirement. It has been engineered for marketing.
Your body at 75, does the design actually work? Now I want to talk about something that the tiny house industry almost never discusses. And I think the reason they don't is that the answer is uncomfortable. Picture this. It is 3 in the morning. You wake up and need to use the bathroom. The room is dark. You are 74 years old. Your right knee has been stiff since you got up too fast last winter. You swing your legs off the bed, stand up, and there is a 4-inch step down to the main floor that you have navigated 100 times. But tonight, your balance takes an extra half-second to settle. Your foot catches the edge. Falls are the leading cause of fatal injury in adults over 65 in the United States. Not car accidents, not heart attacks, falls. And the majority of them happen at night, in familiar environments, on transitions that the person has crossed without incident dozens of times before. A 4-inch threshold does not feel dangerous until it is. Between the ages of 65 and 80, the body undergoes very specific, measurable changes. Grip strength decreases by 25 to 40%. Shoulder range of motion drops. Balance, particularly in low light conditions, degrades in ways that are difficult to notice until something goes wrong. Reaction time slows. These are not signs of weakness, they are normal physiology. But they mean that a space designed without accounting for them is not a neutral space. It is a space with hidden risks. The majority of tiny houses being marketed today, including many that call themselves retirement-friendly, were designed by builders whose primary reference point was minimalist aesthetics, not the biomechanics of aging. The loft bed looks great in photographs. The steep storage ladder looks clean on YouTube. But if you are 72 years old with moderate arthritis and slightly reduced proprioception, that ladder is not a design feature, it is a liability. A properly aging adaptive tiny house looks very different from what you see in most videos. Zero threshold entries, not just at the front door, but throughout the entire structure. No lips, no steps, no transitions that can catch a shuffling foot or the wheel of a walker. The bathroom, statistically the most dangerous room in any home for adults over 65, should have a barrier-free shower, grab bars anchored into load-bearing framing, and a toilet height between 17 and 19 inches. The floor plan should follow what rehabilitation researchers call a one-direction circulation path. Adults with reduced mobility and declining balance fatigue significantly faster when a floor plan forces them to navigate corners or backtrack. The path from bed to bathroom to kitchen should be as close to a straight line as possible. This sounds obvious.
almost no standard tiny house is built this way. And then there is a third issue that almost no one is talking about: cognitive load. A modern off-grid tiny house comes with an inverter, a battery management system, a solar monitoring interface, and a smart panel. And here's what that means in practice. It is midnight. Your phone buzzes. A notification from your home energy app: battery reserve low, check settings. You get out of bed, you open the app. The interface has updated since you last used it. The menu looks different. You try to navigate to the battery screen. You are not sure if you are looking at the right panel. You spend 12 minutes troubleshooting a system you did not fully understand when you moved in, and now you are standing in your kitchen at 12:15 a.m., wide awake, frustrated, and not entirely sure whether the problem is serious or not. That scenario plays out for people every week, and the chronic, low-level anxiety of living with technology you do not fully trust is not a minor inconvenience. It is a form of daily stress that accumulates over months and years and does real damage to cardiovascular health. A well-engineered home energy system should do the opposite. It should be self-managing, transparent, and communicate only when human action is genuinely required, in plain language, not error codes. That's not a software feature, that's a design philosophy. And it's the standard a retirement-grade tiny house must be held to.
The hidden risks inside small spaces. There are 3 technical risks specific to tiny house living that almost never appear in mainstream reviews. Every man over 65 considering this needs to hear them. The first is electrical proximity. In a standard tiny house layout, the inverter and main breaker panel are often located within 3 to 6 feet of the sleeping area. In a full-sized home, that infrastructure is in a utility room, a basement, or a garage, separated from living spaces by multiple walls and significant distance. In a 350-square-foot structure, that separation does not exist. Research on long-term residential EMF exposure is still evolving, but the engineering principle is simple: distance matters. A thoughtfully designed tiny house locates all high-current components on the exterior wall furthest from the sleeping zone. Tesla's vehicle architecture already does this. The high-voltage battery systems are deliberately isolated from the occupant cabin. The same logic should apply to a home. The second risk is solar heat gain through untreated glazing. A single window in direct afternoon sunlight can raise the temperature of adjacent air by 5 to 9 degrees Fahrenheit. In a room with 3,000 cubic feet of total air volume, that adds up quickly, and it does it silently, without triggering any alarm. The solution is thermally responsive window coverings, systems that react automatically to interior temperature without requiring the occupant to monitor and adjust them manually. Commercial buildings have used this technology for 30 years. It should be standard equipment in any tiny house built for older adults. The third risk surprises most people: air quality. In a sealed, well-insulated tiny house, CO2 levels rise measurably faster than in a larger home, simply because there is less total air volume to dilute exhaled breath. Moisture accumulates more rapidly, particularly in humid climates, creating conditions that can support mold growth inside wall cavities within 2 to 3 years if ventilation rates are insufficient. Industry standards require at least 0.35 air changes per hour for occupied single-person spaces. Many budget tiny house manufacturers do not meet this threshold. Here is the insight that connects all 3 of these risks. A tiny house is not simply a small home, it is a compressed ecosystem. Every system interacts with every other system. A poorly placed window raises temperature, which degrades sleep, which increases cardiovascular stress. Insufficient ventilation raises CO2, which reduces cognitive clarity, which impairs the small daily decisions that compound over years. When you evaluate a tiny house, you are not evaluating square footage. You are evaluating an integrated life support system, and the stakes of getting it wrong are not abstract.
Can it grow with you? Here is the question that most retirement housing decisions fail to ask. Not, is this comfortable today? The question is, when my body changes over the next 10 years, and it will change, can this structure change with me? Think about what that actually means. In 3 years, you may need a ramp at the entrance. The framing may not have an attachment point. In 5 years, you may need a wider doorway for a walker. The structural layout may not accommodate it. In 8 years, you may need a second sleeping area for a caregiver. There is no expansion path. A traditional tiny house is a fixed object. You adapt to it, and the day it can no longer accommodate your body is the day you have to leave. Tesla's engineering philosophy, the same thinking behind the Powerwall's stackable design, the Model S software-defined hardware, the way every Tesla vehicle is built to receive capability upgrades rather than become obsolete, points toward a completely different model for housing. A retirement-grade modular tiny house would be a base unit designed from the beginning with engineered connection points for expansion. A bedroom module that attaches in year 4. A covered transition space for weather protection. A shared utility core that serves 2 connected units. The electrical, plumbing, and thermal systems would be sized not for today's needs, but for the needs the structure will be asked to meet in 15 years. That is not how traditional tiny houses are built. It is how Tesla builds systems. And if that philosophy is applied to residential architecture, it transforms the fundamental value proposition. Instead of a fixed object that eventually fails to fit you, you have an adaptive platform that evolves alongside the life you are actually living. If you are 67 years old today, you are not making a 3-year housing decision. You are making a 15-year decision. A structure that cannot change with you is not a long-term solution. It is a delayed problem, and delayed problems have a way of arriving at exactly the wrong time. There is a difference between buying a structure and buying a platform. Most tiny houses are sold as finished products. What you receive on delivery day is what you will live with for years. But retirement is not static. Health and mobility change, sometimes faster than expected. An adaptive housing design anticipates that. Ramps can be added without rebuilding the frame. Doorways can be widened if needed. Utility systems are built with capacity for future demands, not just today's. This is not about luxury. It is about flexibility. At 67, you may not need extra space. At 75, you might. The question is simple. Can your home adjust with you, or will you have to leave it? If a tiny house cannot evolve, it is not long-term. It is temporary. Before you make any decision about tiny house living, I want you to sit with 3 questions. Not overnight, right now, before you close this video. First, if the power goes out for 6 hours in the middle of a summer night, does this structure give me enough time to be safe? Not comfortable, safe. If the honest answer is, I don't know, that is your answer. Second, when I am 77 years old, can I walk from my bedroom to my bathroom at 3 in the morning, in the dark, without holding the wall, without a single raised threshold between me and where I need to be? If the floor plan has more than 1 turn, you already know the answer. Third, does this home work for me, or do I have to work for it? Because the day your home becomes a system you manage, monitor, and troubleshoot, it stops being a home. At 72, at 76, at 80, your energy is not available from managing a device. A tiny house should not impress you on day 1. It should protect you in year 10. Tesla has not officially launched a residential housing product, but the engineering principles behind their best work, failure-tolerant thermal design, self-managing energy systems, modular architecture built to scale, those principles are real, and they represent exactly the standard that every tiny house marketed to people over 60 should be held to, whether Tesla makes it or not. If this analysis was useful to you, I want to ask one question in the comments below. What is the single biggest concern you have about tiny house living after 60? Is it temperature and safety, the physical layout, or whether the structure can adapt as your health changes over the years? Write it below. I read every comment, and your answers determine what we analyze next. If you are new to this channel, we exist for one reason: to give you the clearest, most honest analysis available before you make the decisions that matter most in retirement. No sales pitch, no affiliate links, no agenda except making sure you have the full picture. If that is what you are looking for, subscribe now and hit the notification bell, because we publish every week and you do not want to miss what's coming. Next week, we go into the numbers that most tiny house videos deliberately avoid, the real 10-year cost of this lifestyle, not the purchase price, but land, taxes, maintenance, solar degradation, battery replacement cycles, and the one line item that almost every retirement budget gets completely wrong. It is the video to watch before you make any final decision. I'll have the link right here when it goes live. See you then.